10 मिनट हो चुके हैं। अमित
दिख रहा लाइव?
हेलो
हेलो, yes sir, it's live now. आवाज नहीं है? Okay sir, audio input is there but not a video input from your end.
I know my video it's on now. It's visible now. I'm ready. Okay, Rutvik sir. Okay, Amit, I'm visible.
Yes sir.
My video is on. Yeah. So let's start, Amit, now. I'm ready.
Yes sir. Yeah sir, you are visible now, you can start.
So shall we start? Is it? Where is the stream?
It will take 20 seconds.
Okay, who says start?
Start हो चुका है loading. Hello? Yes sir, we are live now.
Yes, hello.
Okay, we are live.
Okay. So good afternoon, everyone. Right. So today is the first introductory session on cloud computing. So today in this journey, we will understand what is cloud and what is cloud computing and what cloud computing does have a role in your career. So let's do not take much time of yours, and I'll hand over for beginning of the session to the Rutvik sir. So Rutvik sir will take up the first section about the cloud computing, and then I will take up the session of what is Google Cloud Platform and what it does, and based on that, and then in a later on series we will go ahead much more in a depth of that. So let me hand over this to Rutvik sir. Welcome, Rutvik sir. Please begin with the cloud introduction, cloud computing introduction. Thank you.
Hey, thank you so much, Harshal sir. I hope the screen is visible.
Sir, your screen, yeah, your screen is still loading.
Is it visible now?
Yes, sir. I think your sleep is getting ready.
Okay. This time when the screen is getting loaded, uh, I think we have a diverse set of participants today in this series. So, what is our agenda today? I will be
So
discussing
your
about.
screen is still loading.
Fine, Amit. Let it get loaded. Till that point of time, we'll just discuss what is cloud and how it came into the picture. Right? Okay. Today's agenda is, as Sir Arshal sir told you, that I'll be more discussing about what is cloud computing and every developer is talking about this. Let us talk about AWS, or let us talk about VMware, or let us talk about Windows Azure, right? Many of the services or many of the technologies are running on this cloud platform, right? It's kind of a buzzword that is trending right now in IT world, right? IT domain. If you want to define it, what is the layman language of defining cloud, right? So it's a term used to define network-based computing. So when I say network-based computing, I'm doing computation over the network, or my resources computation is provided to me over the network. Now, network can be offline network, or it can be your online network. Talking about offline network, it becomes a special kind of cloud which we are going to discuss. And when I talk about online network, and it again becomes right another type of cloud. So we are going to discuss about these two types of networks, two types of models in cloud computing. But the main agenda is it is network-based computing, which takes over, right? Let us say internet, right? And you don't have to actually have some physical resource to do some computation, right? Now, what do you mean by computation, first of all, right? That I'm telling you to compute over the network, but what is computation? So your computation can be a simple computation like adding two numbers, right? Or it can be a larger computation
बहुत
like
terrible है
fetching
भाई
data of,
सॉफ्टवेयर.
let us say, 1 million or 10 million records.
चल रहा
It
है
can be
जी.
any sort of computation which can be done over the network, right? That is cloud computing. Now, what happens in cloud computing is when you talk about a normal user who uses cloud services, they get connected with internet like we do. We does some computing task, we apply some computation, right? We run our applications on the server, or we can store the data. These are the normal tasks which is done by normal cloud users, right? So we connect with internet, we do some our computing task, run our application, and we store some data, right? So if I want to define in a very short manner that what is cloud computing, right? So it's a computing and software resources delivered over the network as and when required by the user. So it's on demand and it is delivered as a service. Now, what is this on demand and what do you mean by delivered as a service? So when I talk about on demand, say for example, if I press the switch to turn on the fan, I am requesting electricity from the electricity provider. So turn on the switch, press the switch, it will be turned on, and electricity provider will be providing you electricity. Now, at the same time, if I turn on my switch for AC and computer, more electricity is required to operate my AC and computer. So, on demand, I'm asking for more electricity. I'm looking for more electricity. And electricity service provider is delivering this service to me, right? So same way cloud computing can be defined. We are going to provide computing and software resources to the users, to the end user, as and when required by the user. So user will request for such resources, and then we are going to provide these resources. So that is very simple definition of cloud computing. Now, as you can see in the figure, the cloud computing came, or if you know talk about cloud computing, everybody thinks about like it is kind of a server farm. Yes, majority of the cloud service provider, they are providing this cloud resources from their server farm, but it is not mandatory. You can have your own cloud with a single normal computer as well. So when I talk about cloud computing, remember this, it is not always about server farms. They are there, majority of the service providers, but you can do it with single machine also, right? So let us talk about little bit of computing history first of all, and then I'll take you to that journey of cloud computing, that how it came into the picture. So, if you talk about near about 1960, we started the computing era, right? And mainframes came into the picture, right? This is in the background, as you can see, there is a picture of the mainframe computer, ENIAC, right? You know about ENIAC, right? And this was very complex to handle, right? Because even if one bad tube is there, mainframe will shut down, right? And there are actually 19,000 possibility about tubes. There were 19,000 tubes to be used in the mainframe, right? So why I kept this mainframe in this background picture? There is a reason behind it. The reason is when I talk about mainframe, right? It started the era of cloud computing. Anyone, if they are aware about this mainframe computing actually started like a structure of dumb clients or dumb machines. So there was a room in which mainframes were present, and at the same time, it was not possible for companies to invest lots of money for purchasing mainframe for each and every individual. So what they did is they gave access to the schools, they gave access to the laboratories, they gave access to the companies with the help of this dumb clients. And that is how the computing started. But at the same time, the seeds for cloud computing was present at the era of mainframe computing, right? Now, from the mainframe, the computing moved to client server architecture, right? So there was a single server or multiple server and multiple clients. So multiple clients can send requests to the single server, and then they can access their data or their documents, or they can do computation, whatever they want to do, right? And generally you understand this client server approach in the way of request response model. So client will send the request and server will generate the response. The clients are in Now, late 1990s or in 2000, this client server approach was taken to the web computing. So now it was no more restricted to a single, a single building or single organization. It moved over the web, right? So client server approach combined with the internet, it became web computing. So now, rather than restricting ourselves to the single organization, we can send requests to any server which is present in any organization. And we are using this web computing nowadays. We are sending requests to the server. We are getting our Facebook images. We can buy anything on the Amazon or Flipkart like e-commerce websites. Or even we can do simple calculation, mathematical calculation on the Google. We have translators which can convert English to Gujarati or English to Hindi or Hindi to English, whatever we want, right? And that is web computing, right? We send the request, server handles the request and generates the response, and it is delivered back to the client. But in 2010, there was a shift, and the shift was given to cloud computing, right? So from 1960s, the seeds were there for cloud computing, but it was launched in near about 2010. And what is that cloud computing? Why people needed this cloud computing, right? So the reason behind this was when companies started web computing, they actually invested lots of money in, capital expenditure or in buying servers or in investing in infrastructure. Now the expenditure was so huge. If more number of clients were added for that particular service, company has to buy more infrastructure. The company has to invest more in infrastructure. So what has happened at that point of time, it was so expensive for companies to manage their IT infrastructure. In some cases, what happened that if company has hosted their data on single server, and if this single server fails, what to do? What about data, right? So company needs to invest more on replicating the data, right? So the idea, which was something like this, that capital expenditure on IT infrastructure was too costly, led to the innovation, and that innovation generated an output called as cloud computing. The cloud computing focuses on one concept rather than focusing on expensive IT infrastructure. They focused on least expensive IT infrastructure, right? So IT infrastructure will be there, but it will be less expensive, right? And that was the main concept behind cloud computing. Now, to think about the scenario, I think everybody is using laptop or computer or smartphones, right? And if you open your task manager and if you see that how much percentage of computing resources are utilized, you will be able to see that even if you are playing, high-ended games, your CPU utilization won't be more than 40%, or let us say 30. It will be near about 30 on an average, but it won't be more than 40 to 45% if you are running multiple applications, right? Sometimes it goes beyond 50, but it might be your virus or anything, right? So what happens actually when we use this computing resources, they are never 100% utilized. So what people wanted to do is they wanted to use for that huge IT infrastructure, it was never 100% utilized. So what this company thought of, that rather than using this infrastructure for our own purpose, if we can give access to this infrastructure to general public to do their regular computing task, the resources can be utilized 100%, or let us say more efficiently. And the second advantage is we can commercialize this model, right? So the IT giants will earn something out of the resources which were not utilized earlier. And that led to the innovation of cloud computing. So this is how the journey started, right? The cloud was defined, or the concept was defined at the time of mainframe era only, but it came into the commercialization in early 2010, right? Now the question is, those who are new to computing, those who are first year student, second year student, right? Do we use cloud, or do you people use cloud? What's your answer? The answer will be obvious that yes, on daily basis you use many cloud services. We'll discuss about cloud services in details, types of cloud services in detail, but these are some examples where the cloud computing is backbone. You talk about Dropbox where you save your files, or you talk about your Yahoo or Gmail services, or you talk about your LinkedIn or Facebook like social networking websites, or you talk about Netflix or YouTube where you can watch videos. Everyone is using cloud as a backbone to provide services to the user. You might not have seen many of the uh, applications, like you might not have seen Evernote, or you might not have seen Flickr, right? Or you might not have seen Photo Bucket, but there are famous ones like Amazon is there, Instagram is there, YouTube is there, Google Play Store is there, Twitter is there, right? So many of the IT giants, they are using this cloud services, right? So we need to understand that as an IT developer or as a computer engineer, we need to discuss this point, that how, and then later on we will be discussing that how actually you can use this cloud services to develop good IT projects, good IT softwares, right? So let us just have a simple example. Your email service is cloud services. You talk about any email service like Yahoo Mail or Gmail or Hotmail. What happens in the background when you open Gmail or when you open Yahoo? So instead of installing this application on your local machine, on your local computer, on your laptop or on your PC, the application email program is already installed somewhere, right? That somewhere can be any huge server, right? Let us talk about server right now, because I don't want to confuse you people with client server and cloud computing paradigms, right? Let us just keep it very simple, that it is there on a computer. The program is running somewhere on a computer. Server is nothing but it's kind of a computer. It's a machine, right? So instead of running this email program on our local machine, it is running somewhere on remote machine. Remote means it is not present in my location. It might be, but I'm assuming that it is not present in my current location. What you need to do is, once you enter your ID password, your credentials, right? What happens is, in the background on the server, the application will be running. The email program will be running. And what is the role of that email program? The email program, first, it will check whether the credentials you have entered, they are correct or not. If they are correct, what kind of data is associated with your account? So it will fetch the data from the server, from the cloud server, right? And then the program is responsible for displaying this data on your local machine as well, right? So what we can visualize, what we can think about is, we are just entering our credentials and our emails are fetched for us, right? But in the background, cloud is the backbone, right? So once you talk about this email program, what it contains is, it contains storage, right? So storage is present, right? And you are storing your emails on that particular storage space, right? So the software and storage for your account, it doesn't exist in your local computer. It's there somewhere on the remote server. Now that remote server might be in your city, might be in your state, in your country, in your continent, or it can be all over the world, right? There is no specific location, right? So where this data is present, where the software is present, where the storage is present, it's present on service providers cloud. So if you are using Gmail services, it's present on Google Cloud. If you are using Yahoo Mail services, it's present on Yahoo Cloud. Okay. So what is cloud? If I want to define it in single line, right? What is cloud? So cloud is nothing but it is one-stop shop for each and every IT services. You talk about computing resources, you talk about software, you talk about platforms, you talk about storage, you talk about any IT service which can be applied to the IT domain, cloud will be able to host it, right? So, in layman word, it's just one-stop shop for all the IT services. That's all, right? Like it is a mall, right? Computing mall, you can say. When you enter into the mall, you can buy grocery items, or you can buy sports equipments, or even you can buy clothes. Everything is available over there. So same is applicable to cloud. You can buy computing resources, or you can have computing resources. You can have storage service. You can have platforms. You can have software. Anything you can do with cloud, right? So that is how you can define cloud. It is one-stop shop for all the IT services. Now, what are the key attributes of cloud? We will discuss this first of all, and then we'll talk about that what are the different types of clouds and when you should use which type of cloud service, right? So the first and the major key attribute of cloud computing is shared and pooled resources. Now this is something contradictory. It is saying shared and it is saying pooled. That means the resources is divided among users. Still, pooled means they are grouped together. So how it works? So let us talk about Amazon, right? So Amazon earlier, Amazon was involved in giving services for their e-commerce clients, right? So what Amazon did is Amazon purchased lots and lots of servers. Now what can happen? So many of the Amazon servers can be present in India, they might be present in USA, they might be present in different locations, right? Now what we want to do, as I told you, all the servers cannot be utilized to the 100%, right? So what we have to do in that case? So what researcher did, they combined these resources into a group, into a pool, right? Now what kind of pool can be there? So it can be a computing resource pool, it can be a storage resource pool, right? So let us assume that out of my computer capacity, which is of 8 GB RAM, let us say, and 1 TB hard disk, if I'm utilizing only 40% or 50% to the max, still 4 GB RAM and let us say 500 GB storage is available for me, and I can assign this storage to someone else so that it can be utilized efficiently, right? Now I'm talking about only one computer. There are lots and lots of servers available all over the world. There are lots and lots of computing resources available all over the world. If we can combine into a larger pool, that means huge amount of computing resources are available for other users, right? I have a computer access right now, but somewhere some people, some students, they don't have computing access in villages, in rural areas. Can we give this unutilized resources to them? Yes, we can. Why? How? So first, we can earn out of it. That is the question, answer of why. And how? So we are going to share these resources to different users. And for that, we use a concept called as virtualization, and we are going to discuss about virtualization next, right? Second, broad network access. That means cloud services are available anywhere, right? If you go to Antarctica, let us talk about example of Facebook. Facebook is hosted on cloud services, right? Have you seen that one day you log in into your Facebook account and nothing is getting loaded, right? Your profile photo is not there, your posts are not there. Let us say your posts are not there from 2019. Your current posts are there, right? Will you be able to access your post at that time? Yes, you will be able to, right? At any point of time, at any location, let us say if I've created my Facebook account in Vadodara and later on I'm moving to, let us say, Bombay, or even if I'm moving to Antarctica, my Facebook will remain there for me, So that means it means you can access your Facebook services using cloud at any point of time from anywhere in the world, right? So that is how it works, right? Third is it is on-demand self-RAM, or if I need more storage in rack server, I can add a rack like a shoe, right? So I can put my new hard disk into it, or I can put, or I can extend my RAM into rack server, and as and when not required, I can take it out, right? So it's scalable. I can change the configuration of the original infrastructure also as and when required. So Elastic, generally it is handled, elasticity is handled by a cloud service provider, and it is more on the logical end, while scalability is more on the physical end, right? And the last is measured service. Now this is something new, right? This is known as pay as you go model in cloud computing. I gave you the example of on-demand self-service with the help of electricity. Now, what happens? How this electricity service provider will charge you? They charge you based on your usage, right? You have a meter at your house, and if your meter is running, your units will be counted, and based on this unit, your bill, electricity bill, will be generated. So same is applicable for cloud computing resources. Let us say if I'm using 4 GB of RAM for, let us say, 4 hours, and the cost for 1 hour is $20, my final bill will be $80. Now, what will be the advantage of such key attributes? Why this cloud computing is so popular? Let us talk about a scenario. Let us say one of my friend is starting a new company, and he needs to post some services online. He asked me that I want to have professional IT services, how I can host my IT services. So there are two options. First option is you can have on-premise servers, on-premise computing resources. That means on-premises means we have our own servers, and we have our own resources at our campus, at our organization, at our building, let us say, right? And we have to invest lots and lots of money for buying such servers. Understand this? Let us say if we talk about a simple server of let us say 16 GB of RAM, and let us say 32 GB or 16 GB of RAM, and with good storage capacity, it might charge you 2 lakhs to 4 lakhs rupees. So it's a huge investment you have to do, right? Now, if you talk about cloud, let us say I'm starting a new business, I want to have IT services. What I can do is I can ask for computing resources from the cloud service provider as and when required. Let us assume that my business is growing, and it is more and more, it is attracting more and more clients. So I'll require more IT services, right? So for that, I'll need more infrastructure. Again, I have to purchase it from the market, and as you know, the cost is very huge. In case of cloud, again, I will ask cloud service provider to add some resources to my services, right? So I don't have to invest in my capital infrastructure. That it is known as capex cost, right? Capex means capital expenditure, right? It will reduce my capital expenditure. Okay. Let us say we have bad luck, and now our company is not earning much, right? And we want to shut down this company. What about the IT infrastructure investment we have invested on our local premises, right? We have to just bear the cost, right? Bear the loss of that IT infrastructure if we have invested in capital infrastructure. But if it is there on cloud, we can ask cloud service provider to take back their resources, and then we don't have to pay for them. Second advantage of using cloud services compared to the conventional IT infrastructure is your OPEX will be less. So there are two terminologies, remember this: CAPEX and OPEX. CAPEX is capital expenditure, OPEX is operational expenditure. Operational expenditure means, let us say if I have a local server, I'll need a place to keep that local server, a room, physical space, right? Second, I need a cooling machine like AC to cool down the server rooms, because as you know, it produces lots and lots of heat, and if it remains in the uh, hot environment, it might get crashed, right? So I need this cooling capacity, right? Third, I'll need experts who can manage the servers, right? So that is known as operational cost, operational expenditure. When I talk about cloud, I don't have to have physical space. I don't have to have cooling requirements, cooling machines. I don't require even persons, experts, those who are able to manage these services, right? It will be done by service provider, right? So I don't have to think about such things. That is second advantage. Third advantage, when you talk about local environment, you need to generate replica of your data if you want to provide reliable services. Now, generating replica of data will require again more computing resources, storage resources, and there should be a periodic update. So you have to manage it, right? Your IT staff has to manage these periodic updates about the replica. When you talk about cloud computing, the cloud service provider automatically generates replica for your data. So that is huge advantage we have. Reliability can be provided with cloud. Fifth advantage we have is security. When you talk about local services, local IT infrastructure, you have to have experts from security domain as well. You need to implement proper security mechanism to protect your services, to protect your data, to protect your organization from cyber attacks. In case of this cloud computing service provider, they have invested huge in their infrastructure. So obviously they will invest more in their security services as well, right? So they have more advanced security mechanism, right? And they ensure this reliability and security with a concept called as SLA. So what is this SLA? SLA means service level agreements, right? So it is mentioned in their agreement that if anything happens with your data, or if anything happens with the duplication of the data, if the service is not reliable, you can legally sue us, right? There can be court cases, right? But it is mentioned in their service level agreements. So these are some advantages of using cloud computing compared to the conventional local computing, right? Now, let us talk about that how this is possible, that how these huge computing resources, physical machines are given to the normal user for computing, right? So the background for this technology is virtualization. Everything started with the virtualization. Actually, it started with the virtual networks, and then the virtualization concept came in the computing. So virtual means it is not physical, it is just logical, right? And then later on, virtualization had a tie-up with internet, with the network, right? So virtualization plus internet, cloud computing evolved, right? So what is virtualization? Let us understand this, and then let us understand that how it played a major role in the cloud computing evolution, right? So it's nothing but it is creation of virtual. So it's not actual, it's not physical, right? It's virtual, kind of a version of something, kind of a logical entity of something, such as an operating system, or it can be a server, or it can be a storage device, or it can be network resources, right? So it can be anything, okay? And what we are going to do is we are actually generating logical entity rather than having physical entities, okay? So what was there before virtualization? Let us understand that, and let us understand what happens when virtualization was introduced, right? So we had hardware, like we had our processors, computing resources, RAM, storage, everything, right? And then what we had on top of this is we had operating system. Okay, so what has happened? We can run our application on top of this operating system. It can be Windows based or it can be Linux based, anything, right? So on top of that, we are running our application like Microsoft Word, or we are running web.whatsapp or web browsers, right? Or any other application like WordPress you can have, or you can play games, right? Anything can be running on top of this operating system. So we had hardware. On top of this, we are installing operating system, which communicates with our hardware, and we can install applications. So applications send signals to OS, and OS sends signals to hardware. Now, when I talk about virtualization, there is a software or a code, right, which generates logical entity of this physical machine, physical computers, right? And this logical entity is called as virtual machine. In short, in cloud computing terminologies, we call it as VM. But what is VM? It's virtual machine, right? So what happens actually? See this. What happens is, what happens is when you introduce virtualization, you have your hardware, right? On top of this, there is a layer called as virtualization layer, or the technical name of this virtualization layer is hypervisor, right? So hypervisor is nothing but it is a bit piece of code which does the virtualization for us, right? And when you introduce your hypervisor, let us say I have 16 GB of RAM, that is one physical machine, and out of this I want to create 4 different physical machines. So what this hypervisor will do is it will generate 4 logical machine or virtual machine for me. Each machine will be having 4 GB of RAM. So that is 4 into 4, 16 GB, right? So understand this, right? Once you introduce this virtualization layer, you can have your separate logical copy of hardware. On top of this, you can install your operating system. And on top of this operating system, you can have applications. This is one virtual machine. Now, this is one more. Depending on the capacity of the physical machine, you can generate many different virtual machines of different capacity. Now, it might require that out of 16 GB of RAM, my 3 virtual machine can be of 4 GB. And then I can have 2 more virtual machine each of 2 GB, right? It depends on the requirement by the client. Okay, so that is how virtualization is very important in cloud computing, because what they have done is they have combined this resources, they have generated this pool, and now because of virtualization, out of this pool of resources, they are giving small portion of computing resources to the customers. Okay, so there are 2 types of virtualization, type 1 and type 2, right? They call it as bare metal virtualization and host OS based virtualization. We are not going into the more details of virtualization, but to clear your idea, if it is bare metal virtualization, the virtualization layer will be directly involved with the what you can say is with the hardware, right? It will be directly communicating with the hardware. There is no host operating system. Now, let us say if I consider this case, in this particular case, it is directly communicating with hardware, right? So if you can see over here at this point, right, virtualization layer is directly communicating with hardware. Okay, and then on top of this, you can have multiple OS and multiple applications. But in case of type 2 or host based virtualization, what you have is you have this, what you can say is hardware. On top of this, you have host OS. On top of this, you have virtualization layer. And on virtualization layer, you will have guest OS, right? Now, if I talk about type 1 virtualization, right, there are many. Like you have VMware virtualization, or you have KVM, which is open source virtualization, which is a virtualization type 1 virtualization hypervisor. KVM is nothing but kernel virtualization machine, and it is open source, so anyone can use it, right, for creating this virtualization layer. Or you can have type 2 virtualization layer like VMware Workstation, you might have used it, or like Oracle VirtualBox, you might have also used it. What happens in this, there is an host OS like Windows. In Windows, we install this VMware Workstation or Oracle VirtualBox, and then on top of this, we install another OS, or we create virtual machines of different OS, right? So that is known as type 2 virtualization layer. Okay. So now let us talk about uh, deployment models of cloud computing, because this is very much required to understand cloud and what kind of cloud service you will be using. And then I'll talk about services model, right? So there are two types of model, deployment models and service models. If I talk about deployment models, what is this? So let us understand this deployment model with the help of transportation, right? Now, as you know, there are two types of transportation. One is public transportation, and second one is private transportation, our own car, right? Public transportation might include buses, trains, and private transportation can be like your car or your own one. And then there is hybrid one, that is like a taxi, which you can purchase on rent as and when required, right? So you can travel to your particular location, right? So it kind of a private service, but still it is available for everyone. Okay. So let us understand this deployment models in cloud. Actually, there are three different models like public-private transportation. There is private cloud, there is public cloud, and there is hybrid cloud. Private cloud is also known as internal cloud. Public cloud is known as external cloud. And now let us correlate it with the transportation terminology. So say for example, if I have a public transportation service like a bus, anyone can use public transportation service. There is no restriction. First thing, first characteristic. Second characteristic is if I want to use public transportation, obviously I have to pay something, right? I have to buy a bus ticket. Okay. And third advantage is, or third characteristic is, even if I have to pay some money for using this public service, it will be always less than the private transportation, like my car. If I'm traveling to some place using a public transportation, obviously it will be always less costlier compared to my private transportation, like my car. So same is applicable to public cloud. When I talk about public cloud, it's available for general people. Anyone can ask for cloud service. Second, if they are using these services, they have to pay for it. But obviously, when it is public, the payment will be always less compared to the private cloud model. So that is public cloud. What are some examples of this public cloud? So first public cloud is, let us say, Google Cloud, right? Anyone can ask for Google Cloud service and they have to pay for such services. One of them is AWS, Amazon Web Service. Or you can use salesforce.com or Windows Azure, right? Or IBM Cloud, right? There are many examples of public cloud. So the computing resources from this public cloud service provider will be given to the normal user, right? Anyone can access it. You can access it, I can access it, or any of the faculty or any of the student of any of the universities can access it, right? Compared to this, private cloud is more costlier, but it's private. Private means it is reserved for individual entity, right? So in case of computing, private cloud means it is reserved for a particular organization. Now, this private cloud might be on premise or it might be off premise, managed by some third party, right? But it is restricted to a particular organization. So the services from this cloud will be given to only employees or the member of the particular organization. Let us say if I'm having a cloud services for Parul University, it can be given to the students and faculties of Parul University. It's not available outside for other university students or faculty members. That is private cloud. And the third model is hybrid. Hybrid means organization can use the cloud for its internal access, and then some of the portion will be given to the public. Like let us talk about a cloud service which is deployed for federal agencies, for law enforcement agencies, right? So law enforcement agencies can keep their private data in their private cloud. So the members of the police department can only access it, and many of the registration or status of a particular case can be tracked by public. So that can be delivered to public service. That is hybrid cloud. There is one more community cloud which is developed for a specific developers. Let us say a cloud for Google developers, The cloud for Microsoft students, it can be for communities, right? The cloud for machine learning engineers, cloud for deep learning with image processing, it can be different case studies, right? So these are the three deployment models for cloud computing, and there are three service models as well. And we know it as AaaS, PaaS, and SaaS. So this is a bit interesting. AaaS, PaaS, and SaaS. Now, what is this AaaS, PaaS, and SaaS? AaaS means infrastructure as a service. PaaS means platform as a service, and SaaS means software as a service. So as you can see in the figure, I have taken the example of a building where the infrastructure is denoted by AaaS, platform or the base which we are generating is PaaS, and SaaS is something like aggregate or service software given to the user. Now, to understand this in more detail, I'll just give you a few examples and how it works. So infrastructure means any infrastructure. It can be your storage service, it can be your computing service, right? Any sort of computing infrastructure like your RAM or CPU cores or anything can be considered as service, right? Infrastructure. Infrastructure contains everything, right? And actually, when you talk about infrastructure, right, you host something. Let us, I want to host a website. You can host a website on a AaaS service provided by Amazon called as S3, Simple Storage Service, AWS S3, right? So you can host your websites over there. Or you can host your websites on Heroku, right? That is a cloud service which is used to host a website. So this AaaS service, they provide infrastructure, and generally we use it for hosting our application, for conducting some computational research. There are a few examples like Amazon EC2 or Windows Azure, or you can use Google Cloud Services also, right? Second is PaaS. PaaS is platform as a service. What is platform? We build something on the platform, right? In the building example, even if you can say there was a platform, on top of that, the building was created. So this platform is nothing but, you can say, your coding platform. It gives us the platform to create software applications or software modules, right? A simple example, you might have seen this tutorial points software module where you can run multiple or different types of code, right? Or you might have seen W3 school where you can run HTML code, right? So this all are example of, but in more generalized way, like you have used Jupyter Online. So what is this Jupyter Online, which allows you to run Python code online, which is hosted on cloud platform, right? So there are few conventional examples also. You can have Google App Engine, which can be used to create apps. You can have Force.com PaaS platform to create your software development or to create your softwares, right? The third type of service is SaaS, where you consume, right? There is no role of developing over here, right? And consume means the application will be hosted on the cloud services and we are just going to use it. And you are doing that. Dropbox or Google Drive or even Google Docs, Google Slides, everything is example of SaaS, right? So this example is all the Google apps you have, including Classroom, is example of SaaS. The second example, which I would like to, I'm very much associated with this example, is Zoho projects. Now, I cannot interact with you, but if the session was interacted, right, I would like to ask you one question: that who developed this Zoho projects? Right? I am giving you 1 or 2 minutes, and if you know the answer, the founder of Zoho projects, you can post it in the chat, YouTube chat. Right? You will be surprised with the answer that the Zoho project was developed by an Indian. The founder of Zoho project is an Indian, right? And if you can search on the internet, look for this Zoho project. It provides many of the SaaS services, many of the business enterprise SaaS services, and the revenue model is too huge for Zoho projects, right? You should understand the case study of the developer, right? And at the end of session, even you can search on the internet and you can tell me the name in the chat box who is the founder of Zoho projects, right? You'll be surprised that the founder is living in a village near to Chennai, right? The headquarter of Zoho project is Chennai in India, right? Huge IT company, headquarter is in India, right? So that is again example of Zoho projects, right? Zoho again provides applications like Google. You have Calendar, you have docs, you have slides, everything is there, right, in Zoho also. So if you talk about what you have to manage in these three different categories, if you talk about traditional IT infrastructure where you have IT infrastructure on your premise, everything should be managed by you, right? So you are IT administrator, everything should be managed by you. If you talk about what you need to manage, so everything like computing resources, networking resources, operating system, and cloud service provider. Right. So what you need to manage is you need to manage middleware. What is middleware? Which can interact with your cloud service, or you have to handle runtime things, right? You have to manage your runtime queries of the virtual machine, or you have to manage your data only, your applications only, which can be installed, right? Uh, so I think we got the name of the Zoho project. Yes, Sridhar Babu and Tony Thomas. Great, right? They are the founders of Zoho projects. Nice answer, right? They are Indian founders of Zoho projects. Great. Okay. Now, when you talk about platform as a service, right? What you need to manage and what will be delivered by service provider. So in platform as a service, everything, even the middleware and the runtime will be provided by the service provider. You need to manage your application and data. So you are free from lots of tasks, right? When you talk about software as a service, nothing will be managed by you, by service provider. Software will be installed on the cloud server, services will be given by you, and you will be only consumer of the service. This is the last pass and last pass. Now you see that traditionally, and when everything from the networking, from switch to server to virtualization, in LastPass and SaaS, my task is bit relaxed, right? As an IT administrator, I have to manage less number of things compared to traditional IT servers, right? This is cloud computing in a glance. This is second last slide, and then I'll hand over to the Harshal sir for introduction to Google Cloud. So what is this cloud computing in a glass? It gives you everything about cloud computing. So what kind of resources are delivered over the internet in cloud computing? So it's compute and storage services, network services, and application. It can be delivered. What are the infrastructure we have? So it's distributed infrastructure. Understand this. Infrastructure might be present at different location, at different physical location, but they are kept in a pool. Logically, they are together and then given to the service consumers, right? You have resource virtualization with the help of hypervisor. There are two types of hypervisor, type 1, type 2, bare metal and host OS. Bare metal can directly interact with the hardware. Host OS will have operating system in between virtualization and the hardware. There are three deployment models: public cloud, private cloud, hybrid cloud, and community cloud. There are three service delivery models: SaaS, PaaS, and PaaS. And defining attributes are passive infrastructure because we are talking about server farms. It's utility computing. Utility computing means pay per use model. You have to pay for the usage you have done, right? Like electricity. Accessible via internet, so that means anywhere, anytime access, and it's elastic. Means you can stretch it as and when required, you can shrink it as and when required, right? So these are some defining terms related to cloud computing. And these are some service providers, right? There are many public cloud service providers, right? You might talk about IBM Cloud or AWS or Adobe Creative Cloud or Azure or Google Cloud Platform, or let us say Zoho is there, or Salesforce is there, or you might have heard about one of the famous, I forgot, not clicking the name, but there are many cloud service providers in the market, right? These are some public cloud providers. I have not given any insight in private cloud services. So let me just have 2 minute private cloud introduction. If you want to create your own private cloud, it is possible. For that, you need to do two things. First, you need to check the machine which you have, physical machine. It can be your normal laptop only, right? The machine which you have should have VT technology if it is Intel processor, or AMD V technology. It can be checked with the BIOS. You need to go into the BIOS and you can check. It will be in advance, and you can go to virtualization and you have to check for Intel VT, or if it is AMD, it is AMD V. If you have this technology in your physical machine, you can have hypervisor. You can run your hypervisor over there, right? There are many providers, many open source technologies available for private clouds. You can have, say, for example, Eucalyptus is that, which is a Linux version, or you can have Open Nebula, right? Or you can have OpenStack, or you can have VMware vCloud, right? There are many options which can be used to create our own private cloud also. But generally, rather than investing huge on our infrastructure for creating our own cloud, people like to use services from the IT giants like this. Okay, so with this point, I would like to conclude the introduction of cloud computing. I'll hand over the session to Harshal sir. He will explain about Google Cloud. Harshal sir, please. Just a second, sir.
So now we will start with the Google Cloud. Okay, my screen is available. My screen is visible. All can All right. So let's start with Google Cloud because as I've said, what are the services which has been provided by the various service providers. So these many service providers who are having the very much expertise. But today we will talk about Google Cloud. Now, Google Cloud is going to provide us. What is a Google Cloud? Right, let's first start with the three models of that. Very first is a physical colonial model, where what you can have a storage that you can see, a storage, processing, memory, and network. So basically, this is talking about a physical colonial. That means you can configure, you manage, and you maintain. Now, this is your resources. This is your resources we have. So these resources we share and we use distributedly. So this is we have a physical colonial setup. Then you don't have exactly that kind of setup. You have your virtualization power. You have a virtualization. So using this virtualization facility, we create a virtualized environment. We have a virtualized storage. We have a virtualized processing capacity. We have a certain virtual memory and a network also. So is a stage, second one, which is known as virtualization. And there your all major resources is virtually available, as explained earlier. So this is being a provider and managed by provider. In a physical or a colonial structure where user so Google platform provides the three flavors. One, which you want to create a private cloud, Google supports. If you want to have a provider managed version, that's called the virtualized version, Google supports. And this is the third category where it is and which is fully automated. So basically, the Google Cloud is having the expertise in a lot of automation places. So this is a serverless computing, which is a key speciality of a Google Cloud. Right. So physical resources which everybody can develop, virtualize, it can be done by yours. But this fully automated is highly challenging. So let's understand what is that. The collocation colonial, where financial efficiency of renting the physical space, right? You have a shared hosting. We give the resources on a rent basis, and you have that physical spaces, right? So you need to invest in a data center, real estate, to store that many number of capacities of server, right? So your financial efficiency is being also required for investment in a generation of data center. So that actually adds your real estate also in a data center. So we had to come up with the second point, that is virtualized data center of the today, which matching the physical building blocks, hosted computers, CPUs, disk, load balancers, and all the first collocation way of the cloud. Second, Google share the similarities. So you have one feature, one cloud can collaborate with the other cloud. So that means with the private data center and colocation facilities of the big which get and added with the support of all automated tools for the load balancing, disk management, CPU management, server management, and all this. So due to this virtualization, what benefits which we have received, we can directly think, we do not need to think about the physical or our IT infrastructure. We can fast go for a development because are easily available. Previously, what happening? We need to install it, we need to make it ready. Now, ready to use resources are available. So, second important benefit is this will reduce the IT infrastructure expenses. And even though sometimes real estate, which we require. So we don't require, in a post-pandemic or in a COVID world, we don't require to invest in cloud. And that's way that easy the infrastructure maintenance becomes easy. And you can decide, you can control, and the flexibility is you need to increase the RAM. Virtualization can easily produce without the downtime also. So user controlled, user configured environment, which we can get it. Right. So this is having a computing architecture. Understand? The computation engine, compute engine, which is on a AS model, that Kubernetes engine, that's the version, which is on a AS and PAS both. This is which we are talking about the infrastructure. But now that engine comes, which is platform engine. Right? This platform engine platform as a service which provides us an application functionalities. So this is being as the cloud functions. So this becomes a platform independent infrastructure that has become to the serverless logics. Because now you don't need a server which gets for a computing. It's your cloud, it's itself become a server too. So you get dynamic infrastructure. You're not now worried about the computational powers. So this is a serverless is a key advantage in a Google Cloud platform. So you have the all at the end. So Google Cloud Platform Operations, which is what? It's publicly the estimations are available. So Google carries 40% of the world internet traffic every day. You can understand what is the share of a Google traffic in the world. So this is of its kind on the earth. And Google has invested billions of dollars over the years to build it. Right. So it has not been developed over the night. But you can understand what is the share 40% share. And it's the largest network. How it has been developed, we can talk it later on. But see, as an infrastructure, as a such, you get there you have compute, storage, organized in a way to your physical actual data centers. But the model is you pay for what the resources you get allocated. And in a platform as a service, buying your libraries that provides the access to the infrastructure which your application is required, like you are using a Google login APIs in other platforms. So thus that allows you to focus on application logic. You are not worried about the authentication and security. That has been taken care by Google API for authentication. Right. So you can focus on your functionality. So here, what you need to be, you pay for your that you use. So as cloud computing is evolved, the momentum is shifted towards the managed infrastructure and managed services. So people do not invest in time. They just directly start on focusing on their core solutions. Now, let's see how it works. You can see this globe. It's a US here. This is Europe. So now let's do and so this is work on region basis and zone basis. So in a Europe also, it has servers. These clouds are created on a basis of certain servers. So they have created for a Europe there is one region which is called a multi-region layer. And in that region we have the Europe West, right? If it is a Europe West, we have the again subzones, that is Europe West 2A, Europe West 2B, Europe West 2C, and so on as of needed. So these many infrastructure resources are made available this way. It is so what is the purpose of this? We understand here. So regions and zones, regions are independent geographic areas and that consists of zones. These are the locations within the region tends to have round trip of the network under the 5 milliseconds of the 95th percentile. Why I am quoting this? Understand. This is what the Google infrastructure, Google Cloud is faster. So in this region, it would be rooted into that round trip into the network, then shifted to the another cloud over the internet. So now what is a zone? The zone is okay. So we need to have a disaster recovery plan and plan which is we need to know how we can bring up the applications right in case of any failures. And unlikely that your primary region is lost. So you have zonal resources, you have zonal resources, and these zonal resources operate, zonal resources are operate in the single zone. So if a zone becomes unavailable, all of the zone that zones are unavailable until the service is restored. So Google Compute Engine, which has a virtual machine instance, resides within a specific zone. Right, to be resources. So this is the region, and this gives them a higher relative zones resources. So references here, Google Cloud has a now understand multi-regional resources. A few Google Cloud platforms services are managed by cloud, Google Cloud, and that is to be redundant, distributed. So for an example, there is a one region which is Singapore, South Asia region, and there is one Europe region. So continuously these Google are routing among them through our mirroring. So if Singapore region gets down, these services will be available to the world from the other regions. So these services are optimized availability, performance, resources based. So they will keep on providing the efficiency so that services will be coordinated either latency or the consistency will be provided. And these trade-offs are documented on a product for specific business. And the following services have one multi-region deployments. In addition to any regional deployments, right? That is the Google App Engine. Its features Google Cloud Data Stores. Google Cloud Storage and Google BigQueries. Let me tell you that you have a Google Play Store also. So that Play Store is actually Starbucks regional wise. If you operate that in India, the different apps will be received. If you operate outside the India, different apps will be visible. Right? But in case of failures, it may possible sometime that India is a location only, and due to the virtualization, the physical zonal resource, regional resource will be down, but that similar things can be operated logically. So now let's go to the right to choose this cloud platform because this articles build, test, and deploy applications on Google's highly secure, reliable, scalable infrastructure. And it lets you to compute store machine learning applications and all over the web analytics and backend solutions. Right. So what are the services are? And the compute services are at the Google Cloud Platform are this, which is a products and several broadly categorized as a compute, storage, big data, machine learning, networking, and operation tools. Right. So these are the engines which we use, and this consider each of the compute services and discuss why the customer might choose each. So these are the storage, high performance object storage, and other thing which is the backup and achievement storage. So high performance access, which is a standard most projects starts on the standard class, and nearline and cold line and archives, which is archive which is just for the storage, no frequency which is not much accessible. So this backup and archive mechanism which is get it, but the data which is highly and accessed very frequently, which gets into the standard category. All right. So this requires high performance object storage, and others for that there is only single, you can say that single API for all storage classes is used. So if you have a need not bother them where you receive this. Google does automatically. Manage the storage, manage your data, and very efficient way. So it will give you a frequent access and it automatically does best ranking and indexing. So let's understand where it is used. The Google Cloud are used right in such as a business, entertainment, data, social network, everywhere in education, art, as has been explained. In business application, you can see that where it has cooperative, right? Various apps like Mailchimp, Chatter, Google Apps, businesses for business, QuickBooks, storage, box.com, OZ, Drive, and that OneDrive, all are backup for that. Social applications, social networking, Facebook, Twitter, they use this also. Management applications for all managing tasks, tracking and organizing the notes, do the to-do tasks and all this. So, if you want to have a career, what are your prospects? A careers in a cloud computing. A cloud computing is the hottest technologies with the high demand for qualified professionals, and the median salaries will be in the US. This is a data of 2017, 18. Right, professionally they were getting in a around 1,24,300 US dollars per annum. But it's not easiest job. It requires acquires you need to acquire your specialty area. All right. What are the skills you require to understand? So skills for the cloud computing is your storage. You need to understand about the storage, networking, virtualization, Linux, security, disaster recovery, web services and APIs, DevOps, containers and programming skills. Cloud service providers, as you have seen various cloud service providers, you need to understand that to select a correct cloud. But there is a people who are here, they need to have a question. Do I really need a programming skill? Yes, I have an answer. Does coding required for cloud? First of all, you need to understand the difference between public and private cloud. If you are working with the public cloud, lots of managing things are there available, so not to worry much. But you need to good to have those things. Although I'm saying that it is not prerequisite, it's good to have a knowledge of coding as building the application for the cloud and deploying them into the cloud requires a programming knowledge, and especially in private cloud, yes, too much. So this is what where you need to manage in a private cloud. So keep this in your mind. That's all with the today's session. If you have any questions, you can raise us on all social media. Any questions? So if you have any questions, you can post on our YouTube. And YouTube, our people will post questions. And you will post all the questions, and you have if you want to join with the this DSC, the form of registration handles, you can contact and approach us. Even the same with the tinkering. So that's all from our end for the day. So this is what done. Yes, yes, I'm hello to Amit. Amit, please take the chance.
Yeah. Thanks to everyone for this session. If you have any questions, any doubts, you can mail us at dsc@paruluniversity.ac.in, or you can just write in the live chat box. It's open for next 10 minutes. So if you still have any questions, you can ask in the live chat box, or you can contact us at the social media platform. So our team will be there to reply all your queries. Okay, sir. Thank you. I think team has already answered all the questions. So we can end up this session today. thanks for everyone for watching DSCPU, and I hope you all enjoyed. And sorry for the interruption between we had, and we try for next time that it won't happen again. So thanks, and have a good day to all. And if you haven't subscribed our channel, please subscribe to so that you get the future details as well. Thank you.